And welcome back to Maths with Mitch. Today we are going to be looking at the fundamental identity cos squared theta plus sin squared theta equals 1. We're going to derive that equation using the trig and Pythagoras that we know already and look at where it comes from. So let's get into it. Firstly, we're going to start with our right angle triangle, our favorite shape when it comes to trigonometry. So let's draw that out. It can be any size, but let's go with that. This is our right angle here. I'm going to label our sides up in our points. So let's call this and stick to the naming convention that the opposite side and angle have the same letter. We're using big letters and small letters. Using our friend Pythagoras. So remember, Pythagoras said a squared plus b squared equals c squared. And as if I've planned it, I've labeled them up in the side so that holds true. So a squared plus b squared equals c squared being the longest side. Now what we can do is do a bit of algebra with this. So let's divide through by c squared on both sides, as I want to get a 1 on the right hand side. So divide through by c squared, remembering going to do the same to both sides. And on the left, a squared plus b squared, they're added together, so you have to divide through c squared through both terms. So we will have this, and c squared divided by c squared is 1. Now what we can do with these terms here is we can change these into a bit of a different form. So let's just look at that here. A squared over c squared is the same as writing a over c, a times a over a times a over c times c. I could separate those out as two fractions, and that is the same thing. If you were to times those together, you end up with the same result. And another way of timesing the same thing by one another is to say a over c, and then we can square the whole thing. So that would be a over c times a over c, and you get the same result as a squared over c squared. So what we can then do is just get rid of that. We can write that out in a different form. So that gives us a over c squared plus b over c squared equals 1. So that's the first result we want if we're deriving the fundamental identity. So that's what we get from Pythagoras. But what else do we know about a right angle triangle? We can apply some trigonometry. So let's now do that. So remember that you can write out SOHCAHTOA in case we forget anytime you like. I'll always do it at the top of an exam paper, make sure I don't forget. And we can apply here, let's look at this angle, theta. This would then be the adjacent, and this will be the hypotenuse. So we can say cos of angle theta equals adjacent, which is A, over the hypotenuse, which is C. But what we can also say is true for this angle is we could use the opposite, and we could also say sine of the angle theta equals the opposite, which is B, again divided by the hypotenuse C. So we can represent that angle with both cos and sine depending on which information we had. But we now have A over C and B over C. And what we can now do is sub these into this equation. And what you'll get as a result, A over C here, you can plug in cos theta. So we now have cos theta squared plus, and you can do the same with B over C for sine theta squared equals 1. However, I've subbed it in there just to illustrate how I've subbed it in, but the mathematical way of writing that is to say cos squared theta plus sine squared theta equals 1. So when you square the function cos or square the function sine, you're squaring the function, but you've still got this. You've got a single input of theta. You're not timesing the results by one another. You've got a square of the function, and that's how you get to the fundamental identity that you're going to apply in a whole host of different situations. So there we are. Thanks a lot for watching. Please subscribe to the channel, press the bell icon, and please come back for more.